Welcome back to a course on calculus and its applications. Okay, now we are going to start with the definition of a piecewise defined function. Piecewise defined function, that is, a function may be defined in several ways. Okay, the best example is I take f of x to be x if x is a non-negative quantity, and as minus x if x is a non-positive quantities. This 0 is included in both the cases. If you want, you may omit 0 in either of the case. Okay, so what is this? When you try to plot this, what would you get? So whenever your x is starting from 0, x is same as that of f of x. Okay, so here what is going to happen? Minus, in the sense it will go this way, because you are taking negative. Whenever your x is negative, you have to negate it, so it will stay in the positive direction only. What actually it is your absolute of x, right? So simply we say f of x is absolute of x, and mathematically this is the best example and well-known example of piecewise defined functions. And other piecewise defined functions not generally occur. We may define as we wish. F of x is equal to 3x plus 5 if x is greater than or equals 3. Okay, and wait, what? 18 minus x if x is less than 3. So this is other way of defining a piecewise function. Okay, when you plot them in a graph, okay, remember what we have defined, 3x plus 5, right? So let us go back to GeoGebra and plot these things. Okay, let me turn off these things. If I think we may go to a new thing. Okay, so what are we going to do? We are going to plot a piecewise defined function. So my f of x is defined in the way that if my x is bigger than or equals 3, it is defined in the form of 3x plus 5. Okay, and else if else condition is x less than 3, right? So it is 18 minus what was the function? 18 minus x. So 18 minus x. So here, where is the function? You see, this is the function that we defined. Okay, at the point till it comes near 3, the function is behaving in this way. As soon as it reaches 3, it is behaving in this way, right? This is an example of piecewise functions. If you try to plot these things, you will find something of this form. Okay, and the nature one of the natural piecewise defined function, it is not actually a piecewise defined function, it is kind of that. Okay, let me take f of x. Just a minute. Let me go to. Okay, you may define f of x in other ways as well. Simply sin x if x is positive, x is non-negative, and is cos x if x is negative. And let us try to plot this function as well. Okay, this is not the natural one, but these are this way also we may define the piecewise functions. Okay, if x is positive, we are defining it as sin x, otherwise it is cos x. So I think I'll have to give. Okay, we know that sin and cos value lies between this thing. Wait, what happened? If x is So I forget to give this one. Okay, now you may see, okay, in the negative sense it is behaving this way, that is if your x value is negative it is behaving this way, and for positive it is behaving this way, right? Okay, now let us go and see the other concepts in functions. Okay. Increasing and decreasing functions, that is, suppose a function is defined on an interval I. So interval, that is what they have said, it may be a open interval or closed interval, okay, and you can take any 2 points, that is for all x1 and x2 in the interval I, okay, whatever may be the values that you take, supposing they are different values, okay, if these two are different values you can always compare these two values, right? So compare that one. Let us say x1 is smaller than x2. If you take the other way also it is well and good, fine. If you have x1 less than x2, in this case for all values we are talking x1 less than x2, if this implies the same inequality in the function also, this function is said to be an increasing function. Suppose this implies the other way, f of x1 bigger than f of x2, it is decreasing function. Here in the definition, while specifying about x1 and x2, I have x1 smaller than x2, whereas here doing the comparison I am taking the other way, okay. You just remember this thing and this will help you identify whether your function is increasing or decreasing. Suppose you have to check the function is increasing or decreasing, these two are the key points that will help you, okay. Take have this, okay, x1 smaller than x2, or you may take what, if you are taking x along with this x, take x plus 1. You know that x is of course smaller than x plus 1, right? So find x plus 1 and f of x, okay, find this and find this value. If see, if this is positive then your function is increasing, and if this is negative, that is f of x plus 1 minus f of x is less than 0, it is decreasing, right? And if you see these things from the graphical point of view, the increasing function means it will go this way and decreasing means it will come this way, right? So I think these things you may try and plot in GeoGebra, or you may take any functions and do the calculations. Let me move to the next one, that is even functions and odd functions, that you might have studied in school itself. Let me repeat it again. In the place of, you have f of x, right? So in the place of x you will have to substitute minus x. If the resultant is same as that of f of x, then your function is even. If the resultant is minus times of f of x, then your function is odd. Sometimes these two may not happen. Let me give you an example. F of x is cos x, okay, let me take, and f of x is sin x, let me take, and f of x is e power x, let me take, okay. In order to distinguish, let me take f1, f2 and f3. This f, g are simply the notations. You may give whatever you want. Usually we are used to taking f to represent a function, that's it, okay. f1 of minus x, so cos of minus x, we know that cos of minus x is same as that of cos x, right? So this is an example of odd function, right? Here what, f2 of minus x, that is sine of minus x, this is minus sin x, so this is minus of f2 of x, right? So this is an example of odd function. Here if you give f3 of minus x, it is e power minus x. This is neither equal to f3 of x nor equal to minus f3 of x. So this is an example of neither odd nor even. Okay, and when you try to look at these definitions in the graphical point of view, the odd function, if something is odd, okay, let us plot these functions in the graph and see what is an example of odd function and the even functions. Let me delete these things. Okay, we have given cos x as the example of odd function and sin x as the example of even function. Apart from this, do we have any other functions? Yes, any even power of x is an example of even function, and any odd power of x is an example of odd function. So let us see from these two functions and let us go back to cos and sine. Okay, here what is happening? First let us look at x square. So whatever is there in the first quadrant is there in this quadrant as well, right? So it is symmetric about y-axis, right? Whatever is there in this side is also this side, so it is reflected in the symmetric way. It is symmetry about y-axis, whereas x cube, whatever you have in the first quadrant is the same in the third quadrant. Okay, it is symmetric about origin. Via origin it is being symmetric. Okay, so you may ask, this is also passing through origin, so why can't I say this is symmetric about this thing? For that, let me give you another example. Right, let me take absolute of x. This also passes through origin. I think let me work it out and give you an example in the next lecture. Now we shall proceed. So if something is symmetric about the origin, then we call it as the odd function. If it is symmetric about y-axis, it is called as even function. Now let us check the symmetry of sine. Okay, what? Here how is it going? The same thing is going here, right? Okay, whereas when you look at the cos, see this cos function. Okay, we have found the example now itself. This cos function is not passing through origin, but still whatever is there in the positive side of x is same as that of in negative side of x. So it is an example of function which is symmetric about y-axis but not passing through origin, right? So let us get back. So if we want to work out few problems of checking these things, let us do. Let me check. Okay, f of x is 1 upon x. Let us check whether this is more increasing function or decreasing function on the entire. This is not defined at 0, so open at 0 comma infinity. Okay, we know f of x is this, so f of x plus 1 is going to be 1 upon x plus 1, right? So what is f of x plus 1 minus f of x? This is 1 upon x plus 1 minus 1 upon x. When you take the LCM, you will get x minus x plus 1 upon x times of x plus 1. So this is x minus 1 upon x times of x plus 1. This is minus 1 upon x times of x plus 1. You know that x can take values in this interval, which means x is a positive quantity. Whenever your x is a positive quantity, of course x plus 1 is a positive quantity. Your denominator is a positive quantity. Hence what you get is your f of x plus 1 minus f of x is a negative quantity. Hence f is a decreasing function. Right? And if you check for whether this is odd function or even function, f of minus x is going to be 1 upon minus x. This may also be written as minus 1 upon x. This is minus times of f of x. Hence it is an odd function. Right? Thank you.